T-tests are popular hypothesis tests used when you have two groups of data and want to compare their means. In the Data Analysis Toolkit, these are accessed through the Multiple Plots and T-tests button. In an earlier video, we saw a comparison of day shift and night shift production, and it looked like day shift was producing more on average. But graphical evidence doesn't amount to statistical proof. So to say we've proved there's a difference, we need a two-sample t-test. And here's where it's located. The whole t-test section is here, off to the right of the box plots, so that you follow the logical progress through graphical and then on to statistical analysis. The section is visible only if you have two columns selected, no more and no less. You can see here the sample size for each group and their average together with their standard deviations and the standard error of the mean. Then below that we have the difference between the two samples. In this case, day shift produced just over 5 more on average than night shift. And next to that is the 95% confidence interval for the difference. Finally, over here we have the calculations that lead us to the p-value. The p-value is the probability that the difference could be explained by the random variation in the data. If it's below 0.05, that means there's less than a 5% risk that there really is no difference between the two groups in the long run. In this case, the p-value is 0, so we have pretty conclusive proof. Now there's a variant on this test that can be used if your data is paired, and we'll go back to data entry to give you an example of that. Here we have a number of tasks. Each row is a different task, and they've all been performed both with the original software and some new software. This could be preparing an invoice or predicting the weather, it doesn't really matter. The important thing is that we have side-by-side comparisons for each individual task, and that's what we mean when we say the data is paired. I'll go back to the plots and I'll change the selection so that we're using this data on processing times. So get rid of those two and then tick these two boxes for processing times. The time series plot gives a pretty clear picture, I think. It really seems obvious that the new software provides a lower processing time than the original one. Scroll along to the box plots and the picture's not so clear, because in amongst here is all the variation from one task to the next that muddies the picture. And scrolling along further to the two-sample t-test, and indeed we've failed to prove a difference. So here's where the paired t-test comes into its own. As the data is paired, we can select yes in this box, and these additional calculations now appear. And these are based on the individual differences in each row rather than the data as a whole. And we can see now that we are indeed able to prove that the new software is faster with a p-value of 0.003, well below the 0.05 threshold. In the next video, we'll take a look at ANOVA.